Hello and welcome back to the Building HVAC Science Podcast. We're out here trying to create better, more knowledgeable HVAC and building performance technicians, contractors, implementers, by helping the two professions better understand each other. This podcast aims to make customers happy in the homes and buildings they live and work in. Today we take a little different tangent. We speak with actually someone who is involved with the real science of building. It's Ben Hildebrandt. He's a really passionate advocate for building science and green technology education at SAIT, S-A-I-T, the Southern Alberta Institute of Technology. He'll share with us in this episode his winding career path, but it sounds similar to a lot of other career paths that people we interview on the podcast. His goes from auto mechanics to aircraft maintenance to architectural technology, and how his journey has shaped his deep commitment to sustainable building practices. He discusses the role of applied research at SAIT, highlighting his focus on real-world implementation of green technologies in residential and commercial buildings. He also talks about the challenges of deep energy retrofits, labor shortages, and siloed efforts within the industry. We hear about that so much. And he offers insights into training programs aimed at bridging these gaps. Our conversation also explores comfort, thermal resilience, and the importance of integrated mechanical systems with the building envelopes to avoid costly failures. This should appeal to most people listening, to regular listeners of this podcast. We hope it does. And we found out a fun fact. Ben has listened to every one of our podcasts. Thank you so much, Ben. We appreciate the attention, and we gave you the platform here to share your passions. So onward with our conversation with Ben Hildebrandt, breaking down silos, the path to better retrofit training.
Hey, everybody. Welcome back to the Building HVAC Science Podcast. Eric Kaiser here, Mr. Bill Spohn right over there, and with us another special guest today, Mr. Ben Hildebrandt, all the way from Southern Alberta Institute of Technology, or SAIT, up in the northern country, Canada. Ben, thanks for joining us today.
Hey, not a problem. It's a pleasure.
I understand you're a, how do we put that, long-time listener, first-time caller here?
Yeah, I guess posting and sharing some of the amazing interviews you guys have had doesn't count as calling in quite. But yeah, I've been listening. It's actually another Calgarian that was actually the first episode I heard. Robert Bean was right when I first came across the Building HVAC Science Podcast, right in the early days, and learning about his perspective on thermal comfort. And ironically, I've had a couple conversations with him virtually, but despite him being in Calgary some time of the year, and anyone who's not traveling, spreading his amazing knowledge on thermal comfort and indoor environmental quality, haven't been able to connect with him in person yet, but soon, hopefully.
Yeah, I was going to make note of that. I looked on your LinkedIn profile, and you were in the same group, Thermal Comfort Principles, Robert's group, that he created largely to share the book, the publication he came up with.
Yeah, it's great work he's doing on thermal comfort. And I think thermal comfort, and we'll get a lot more into conversations on high performance homes, whether it be new build or retrofit. But I think thermal comfort is one of the key aspects that we need to have more of a conversation with, not just in the industry, but also with the homeowners and building occupants as well. Because in Canada, when we look at the energy efficiency piece, it's not, in the vast majority of cases, it's not necessarily a financial decision, unless you're in a really bad building to start with. In Alberta, we look at our utility rates and how the cost to retrofit an existing home and how you recover that cost back, how many years to get that back via utility savings. We're talking 50, 100 years a lot of the time. But there are so many other benefits like thermal comfort and the indoor environmental quality that you gain from retrofits or from constructing a building better to begin with. My big question that I think about a lot is, how do we get that in the day-to-day conversations and in the public conversations as well?
So let's get some background for listeners on who Ben is and how we got to this point, and were there any steps, side steps, or missteps?
Not really side steps or missteps. It's just a lot of turns along the way for me. Like, actually, some of my colleagues over the years, I mentioned, oh, when I did this job back in the day, when I did that job, how many different jobs have you had? And I've been in my current role at SAIT for 7 years, for a bit of background. So I'm not continuously hopping and jumping around. But I started off in high school, actually involved in automotive mechanics. It started with me wanting to learn how to change the oil on my mom's car. And I just fell in love with it, did great in it, and I excelled with that in high school. And then I started apprenticing with that in Alberta here. And then I went off for a couple years serving the mission for my church. And I came back and what career do I want to get into? For me, family is a very important thing for me and being able to support a family. And so my goal, and it's harder now today than it ever has been, but how can I ideally support a family on a single income? And I looked at automotive mechanics and said, yeah, it's a bit tight. And I also saw some guys that are having back problems not too many years down the road. And I ended up getting into, I've always been interested in architecture, which is where I'm at now, but it was way too artsy for me in the early days. So I actually got into aircraft maintenance to begin with. And I had a few random jobs along the way to pay for school, getting into cabinet making from a high volume shop, not apprenticing in it, also doing a bit of concrete, flat work, landscaping work, among a bunch of other random jobs, welding, making car mufflers, high performance muffler several months too. So a lot of different steps along the way. My big first career move was in aircraft maintenance, and I really excelled at that and enjoyed it. But then it was through getting to know a couple other people in my personal life that had done architecture. So I'd thought about architecture was you have your architects who make all these fancy renderings and really cool drawings that looks great and design these amazing buildings. And then you have the architectural technologists, which is my role by training. My initial impression was I would sit at a computer and I have an architect standing over my shoulder with his arms crossed, telling me where to draw the lines. But it's through knowing a couple people in my personal life, one a custom home designer and another worked for over 2 decades at a large commercial architectural firm in the senior management in Calgary, who they just did architectural technologies for training. And it's very broad. There's so many areas you can do and you can take it that I decided, okay, I'm going to make the shift into architecture. And that shift from aircraft maintenance to architecture for me, that happened in 2011. So actually when I got into the field in aircraft maintenance was right in 2008, right before the crash. And I reflected many times, if I went into architecture, I totally would have been laid off the fall after I started in the industry. So it's a blessing in disguise to be in the aircraft maintenance field first. But it also gave me that transition from one field to another, gave me a lot of knowledge of specific technical areas that I'm able to apply into architecture every day in just basic electrical systems. A Boeing 737 has similar, all the same concepts of electrical systems as a city has, just on a smaller scale. So it's what one of our instructors taught us and gave that analogy and be able to apply that. When I graduated from the architectural technologies program at SAIT, I did aircraft maintenance and architecture at SAIT as well. So I'm a big SAIT fanboy. Technical schools, polytechnics, I think that's the way to go in my mind, especially addresses all the labor needs that we have now for skilled labor in the workforce. We need more people getting into fields like this. But going into the architecture, because I had a background in aircraft maintenance and a heavy training in electrical systems, I was able to actually start with, as a student in the current research group I'm with now, looking at photovoltaic systems and eventually started helping out with other areas of green building, which had always interested me. I graduated, worked for a small building science, building envelope firm in Calgary for several years. And the big realization for me of that crossover between aircraft maintenance and architecture for me in doing site inspections on buildings where they're finding issues. It's like, I'm used to crawling a wing of a plane looking for a 1/4-inch crack. It's way easier to find like some moisture failure or something on a building. So that was a great realization for me and understanding some of the concepts as well. So I think for anyone listening out there that's considering like a career change and like, is my current career a waste? If I'm just going to move on to something else, it's definitely not a waste. There's always crossover, always things that you can apply from one career to the next. But I did several years working for that small building science firm, and then a position opened up at the same research group, and I've been back at SAIT under the Applied Research and Innovation Services Hub, working for the Green Building Technologies Research Group for 7 years now, and currently leading the majority of the research in our building and material sciences projects.
SAIT's obviously a big part of your background engagement now presently. Can you explain what that is and where it fits in for listeners who may never have heard of SAIT? And it's Southern Alberta Institute of Technology?
Correct. Southern Alberta.
And that means like Southern Alberta, like where all the beaches are and stuff?
No, we're in the middle of the prairies. There's no beaches here.
Okay.
So I'm at, where are we, about 3-4 hours north, depending who's driving, from the US border in Calgary. So nice prairie winters. Cold climate heat pumps are a really good discussion here. But Southern Alberta Institute of Technology, we're a polytechnic. Colleges and polytechnics in Canada are the ones that handle a majority of the trades training and more technical hands-on training in the industry. There's a few bachelor's degrees that are offered here, but mostly it's a lot of 2-year technical diplomas from architecture, civil engineering, mechanical engineering, electrical engineering. We have a massive school of business, a lot of courses and programs in the energy, oil industry sector as well. We have a whole health school and a lot of programs in there, in addition to the trades. I'm a big fanboy for SAIT, especially when there's a field that's technically related, such as architecture. Rather than spending 4 years getting a bachelor's and then another couple years going for a master's degree, let's just get a 2-year diploma, very hands-on kind of project focus and a lot less artsy theory-ish. And you can see in 2 years if this is a field you really like and you get practical skills. When I came out of the architecture program at SAIT, I could do a building permit set of drawings for a residential home, no problem. And almost there for a commercial building. There's a lot of other fields and specialties involved in commercial as well. But I really like the hands-on feel. And I tell my kids now, my oldest is graduating this year as well. It's like trying to get them go into SAIT and do a program. The other thing too I like with the polytechnic model is the vast majority of programs, you sign up for the program, every course you take relates to what you want to do. Not like I don't want to get any universities hating against me, but the thing for universities with me is I want to take this program in a university. I was like, okay, here's your required courses, plus take another half dozen courses of whatever you want that doesn't relate to it. If you want to go in, get training, finish and get out and have usable skills with a very high employment rate within a year of graduating, like a polytechnic or trade school is the way to go.
It sounds like it's a lot more similar to the community college model in the US. Now, I've talked to some people about how Canada does that, and I'm curious, your schooling and certifications a lot of time, even especially in the trades, are part education and then part apprenticeship in the field. Is that correct?
Yeah, the majority of trades across Canada, and I'm very intimately familiar with Alberta, it's a model of 4 years where you do 8 weeks of schooling and then you work for the rest of the year to build up hours. And you repeat that 4 times over, write some exams, and then you get your journeyman certificate. And then there's also there's a certain, I think is it the Red Seal or the Gold? I think Red Seal certification is another exam you take. And then that training is recognized across Canada for that trade.
Interesting. And I'm guessing those are pretty rigorous programs then to go through with 8 weeks of schooling plus the rest of the year being in the field. Is that at like a specific employer then, or is that at a school, working at the school?
That's with employers out in the field. Like when I was in high school, I actually started apprenticing for a local Ford dealership in Calgary here. I had my hours for my first year of apprenticeship. I could have gone to school and taken the schooling, but I ended up switching into aircraft maintenance and not carrying forward with the automotive mechanics. But generally, the vast majority of trades, you start working green for an employer. And then after you get a certain number of hours in, then you go for your first year of schooling and then carry on. There's also some schools, SAIT has several programs where they offer a pre-employment option where you basically do your first 2 years of schooling before you go out in the field and start working. There's different ways of tackling it.
Is there like a green building program there? Green building center technology? How does that come together and what does it do for the world?
Yeah. So at SAIT, we have a large applied research division. Now, polytechnics and colleges across Canada have really just been getting into the research sphere in the past 20 years. We discussed a little bit before we started recording here about how universities generally do a lot more of the foundational research. Let's develop a new battery technology. You hear a lot of that coming out of MIT often, of different materials. How can we use a more efficient battery that'll cycle longer or have a better power density or whatever? So there's foundational research like that. developing like really cool ideas, really cool technologies that are innovative in different areas. But when you look into the applied research, which a lot of the colleges and polytechnics focus on, that's more how do we take that new battery technology and how do we implement it into a building? For example, there's technology I came across a few years ago at the University of Alberta that some students had developed up there, which is using a nano coating over glass to redirect the sun's certain spectrums of the sun's rays that can generate electricity towards the perimeter. And then they basically line the perimeter of the window with a tiny solar cell to generate electricity while you still look through pretty much a normal window, which is a really cool technology. I haven't seen that to market, but conversation I had with them was like, okay, you guys are ready to put these windows in some houses and monitor how that's going. That's where the applied research comes in. We've done over, I think maybe as many as 24 homes over the past 20 years since our specific green building research group at SAIT started, where these homes are, in the early days, it was how do we do a net zero home, a home that produces as much electricity as it consumes over the course of a year, and putting lots of different systems into it, like gray water recovery and rainwater recovery and reuse within the home, putting photovoltaic system on the roof, and how can we have an in-floor hydronic heating system where it can be recirculated from the south warm zone in the house to the north cooler zone, and like all these different technologies, putting it in together there, putting those different technologies together into a home, but then seeing how it works and monitoring it. So we've done many homes over the years where we're putting new technologies and systems in place. We did a project right now, a building that was constructed up in Nunavut, up in Cambridge Bay. If you look on the map, it's like an island north of the continent of North America. And we worked with them on what can we do for a super high performing community center to provide some cultural training to help pass the knowledge of past generations of the people, the Indigenous peoples up there over it. And not just here's a building to be inside, but how can it give tribute to the local cultures, but be high performance, and how can we incorporate solar into northern climates like that, where you have weeks of sun and weeks of darkness in the year? How does that work? So those are just a couple examples of types of projects we've worked on. We also do a lot in some of the material development as well. If a manufacturer is trying to bring a new product to market, especially a lot of these startups, early days, they don't have a full R&D department to help flush things out like some of the well-established international manufacturers out there, but we can help them bring their product. We use the term of technology readiness level from that paper napkin sketch. You start there all the way to being distributed in the market. Maybe it's a new tool going on TruTech's website, and we help with bridging the gap or addressing steps, moving that technology from a napkin sketch all the way to reality and being in the market. I've worked with different products in the hemp world and applications of hemp. This is several years ago, before there were as many manufacturers in North. There's still not too many. There need to be more, but manufacturers of hemp insulation, for example, in North America, like we did some work with hemp manufacturers making other products, and what can they do in the building industry? We've also worked with magnesium oxide alternatives to Portland cement for different products as well. A lot of that product testing, but also we're looking at the assemblies as well on the building envelope, and how can we build better homes beyond the standard code practice, which in Canada right now, current code construction is a 2x6 wall insulated with an R20 or R22 fiberglass bat. You sheet that and put cladding on it. That's our standard system. If we want to get much higher performance energy-wise, we have to look at what are the different systems. Do we just add a mineral wool insulation on the outside, or is it a foam insulation? Do we do some Larson truss assembly to create a cavity outboard that we insulate with cellulose insulation or something else? A lot of these different ways to add insulation require different competencies for the trades on site. We work as well with helping provide training to the industry. So we look at how can we simplify the process and de-risk the process. A lot of local builders I've spoken with, high volume builders building hundreds of homes a year locally, they're concerned with adopting new technologies or new systems to build, and are they just going to create issues because their trades, their labor on site aren't able to pull it off well? So we look at how can we minimize that learning curve through training? How can we move some of that learning curve into a classroom or a lab? But then how can we look at these different assemblies and say, what's the best one for this specific use case? Because there's not one wall assembly to rule them all or one ring to rule them all. But it's that classic answer in building science. It depends. But what are the considerations? We've done a lot of work in the past couple of years with different nonprofits that are focused on providing training to the industry and spreading knowledge around how builders can build better homes that are higher performance as well. And beyond the building envelope, I will say quickly too, we have other areas of research we look in our lab. We're very holistic of the building as a home. We're very holistic in the building as a whole. I focus on the building and material science end, and I have a few colleagues supporting me, but we have other focuses of research in our group looking at energy management systems within a building. And that's getting into that real cool. There's been some pilots going around across North America and the world looking at load management and time of use and how can we get into that. And so we're looking at that area as well. How can we and our lab also is a research space. It's a living lab. So we are looking at right now, we're developing a new integrated renewable technologies lab. How can we integrate different renewable technologies and different energy systems and battery systems into a home or a commercial building? And what are the different use case scenarios and how does that all play out? How does it all work? And then we also get into the architectural, environmental ecology end of things, like healthy buildings, focusing on the carbon content and the emissions and the impact and how these buildings impact the occupants and the environment as well. So we do the whole gambit of things. I'm a big squirrely. I love looking into and learning different things, but I try and focus on the building science end of things. That's my background in being, and I will say really quickly, when I got into architecture, I've always been really interested in green buildings, sustainable buildings. How can we make buildings better for the environments and for the occupants? But spending several years on building science helped me to realize that it doesn't matter how green you make a building. If you mess up on the building science, and that could be on the envelope or the mechanical system, you can create so many issues with that building that can make life miserable for the occupants. And in worst case scenario, you can spend tens, or I've seen directly hundreds of thousands of dollars of repairs required on a single family home that can be less than a decade old.
Wow. You're going through a big list of things there. And there was something that called out in my head. Like, I never heard any comfort research in all of that list. So have you done any research on how to make them more comfortable, or if the changes that you're looking at, do they increase the comfort in that building?
Yeah. So direct research on the comfort, haven't gotten into. We're looking for opportunities, and we've been in conversations with Natural Resources Canada, is a federal government funded research arm up here, and they have some groups, and we've been in conversation with them that are looking at the thermal comfort piece, and especially starting in, my years are getting messed up. We had some really bad heat waves in Canada the past few summers, and a few summers ago, I think it was 2021, I might be incorrect on that year, the town of Lytton in BC, 1 week hit the all-time heat record for Canada, and the next week the town burned to the ground from a forest fire. Whenever all that forest around it was dry kindling and it's still really hot. And so in Canada, that comfort piece is really looking at that heat resilience or minimizing overheating. And that same summer, there's lots of, we don't want to get too dark on this podcast, but tragically in BC and some other areas of Canada, that same summer, there were many, many deaths due to overheating to people who didn't have air conditioning or heat pumps to provide cooling. That air conditioning conversation in Canada has been very small, but it's been growing a lot in the recent years. So that thermal comfort piece is great. And we're, as a research group too, we try and be really collaborative. As I said, we're talking with research groups at Natural Resources Canada and understanding what they're doing and where we can support what they're doing. I do have a colleague, Prachi, on our team that joined us, and she comes from India, and her master's degree in architecture, her thesis was focused on thermal comfort in residential buildings in India. And it's great to have her on our team, and we're trying to see where we can dive into that thermal comfort piece. But it's really the envelope and the mechanical systems working together. And that's actually my favorite part about listening to the Building HVAC podcast, is it's not just a whole bunch of HVAC jargon and discussions all the time, but you guys do get into the building envelope as well and recognizing the need to connect the two. You've had multiple guests on talking about how they've been in HVAC sometimes for decades, and they're looking at how can we get into more on the building envelope side and how they work together. And where I'm looking at as well, personally, I know the building envelope side well, and I'm trying to learn, and this podcast has been a key learning for me, is understanding the mechanical systems a lot more in homes and buildings.
With all the work you do, I'm going to ask you two parallel but vectors going the opposite direction questions. What excites you the most and what frustrates you the most?
What excites me the most? I think the thing that excites me the most is the opportunity for things to improve. And you see more and more people are becoming aware of these things. So we look at the high performance industry. It's been growing over the years, but we're still far away from that upwards trajectory on that hockey stick of growth we need in the industry. But what excites me is the increasing awareness of things and more people becoming competent in the area and willing to tackle these strategies. And also what really excites me is the collaboration that happens. I have multiple conversations with local residential retrofitters, taking old homes and making them net zero energy performance in the Calgary area. And there's a few of these contractors, they're competitors, but they're still willing to get together over some beverages and have some great conversations and discuss what's working and what's not working. And for me, the exciting thing is the collaboration and the opportunity for that, not just in the research, but also on site and getting these projects moving forward and more successful. What was the second part there? What frustrates me?
Frustrates, yeah.
The days are too short. There's only 24 hours. And actually, on the research side, we have a lot of conversations with other research groups across Canada, both on the college polytechnic level and also on the university level. And we identify, hey, you're doing great work. We should definitely collaborate. But then the current structure right now, we're largely stuck in completing our current research projects, and there's not enough time to really focus on that connection and collaboration, which things are going better. We're carving out that time, but it seems like there's barriers to, and it's not due to people not being willing, but the frustration is like the connections are not as easily obtained for collaboration as we would like sometimes. And I think to maybe sum that up in a more concise point, the frustration, and actually maybe the editor can take this out and just use this as a much more concise. I've been very run on. The frustration for me in the industry is how many silos of initiatives and work that are currently ongoing. So many people are doing a lot of great work, but we're too focused on the work that we don't have enough time to connect, even in the planning stages of these projects. That can be really frustrating. On the school training level, several years ago, I was developing a training program for how do we fill the knowledge gap on site and in design between current code construction homes and building higher performance. We were about halfway through developing this program when another polytechnic in Canada launched a very similar program. And I don't care about competing. The frustration for me is we got our funding, they got their funding, and we worked on our own and developed something that when we're talking high performance buildings, regardless of where you are in North America, the theory is 90% the same. The only thing that changes is a bit of local climate context and local code requirement context. Whereas if we could work together in developing a larger collaborative program, then those dollars can work together and create something that much bigger. And so my frustration is seeing all those silos out there, and I think of how can we break those down and connect better. And on that note, I do have a project I'm working on right now in the residential retrofit space. We identified through a previous smaller project where we developed a guidebook. I can provide you guys the link to share for downloads. It's on high-level process focused. Here's how you complete a deep energy retrofit for residential as a contractor. Here are the key steps you need to take. In that process, we identified the infancy of the retrofit industry in Canada and what we need. There's over 10. We have fewer homes than the United States by a long shot, but looking in Canada, we have 10 million homes that need to be retrofit before we can achieve net zero on the building side. And that's a lot. And if we look at that 2050 emissions goal that Canada has as a nation to be net zero emissions by 2050. 10 million homes is a lot to achieve by 2050, and we're falling very, very, very far short of the trend we need to be on. And we don't have the educated labor needed to complete that. And it's not just the need for here's an afternoon of training or here's a 1 or 2 day training course. It's really in-depth understanding the process and the building science you need to know. In much of Canada, a lot of the contractors working on site that are dealing with the building envelope, the insulation, the air vapor barriers, controlling that moisture movement through the wall, all the things that are important in a wall. Much of Canada, those contractors doing that work have zero formal training. It's not currently captured in the trade in Canada. And that's one of the other frustrations. But we recognize the need for contractors that are looking at getting into deep energy retrofits as the industry grows. What training do they need? And so we got funding through Natural Resources Canada, and we're currently piloting a 5-course program to provide that training. And it's collaborative as well yes, we're developing it. SAIT's going to own that course content. But from the development stage, we've collaborated. We've brought schools, other polytechnics and colleges from across Canada into the conversation as we've been outlining the curriculum and developing it. And now we're piloting it. And I've got instructors from several other polytechnics across Canada sitting through the pilot of the program with me as we're going through it. And we'll be launching it in the fall. And it's going to be really exciting to see not just this course that's going to be popping up at SAIT, but it's going to pop up across the country. And it's going to have valid training for residential deep energy retrofits and eliminating one silo.
Yeah.
So is that course modular where if, say, somebody can't do a full deep energy retrofit on a structure, like they could pick out pieces of it to where, okay, this is a really big thing. We can apply this knowledge to a structure or this piece of it to a structure.
Yeah. The course covers the whole thing. And I think maybe if we could go on a bit of a side tangent, if you'll entertain me here. For deep energy retrofits, I like what Peter Amarongan, who's the president of Retrofit Canada, I'm on their board of directors currently as well, but he talks about the need with a deep energy retrofit to start with a full plan. Where's the house at now, and what's it going to take to get that house to net zero? Or as he puts it, what's the best version of this house in 2050? And then you identify from seeing where you want to get to, what are all the steps along the way? You create that plan, and then it's like, okay, can I do a whole one shot, as we've been calling it, a one-shot deep energy retrofit all at once, which in Canadian dollars in the Calgary area, that's ranging from $150,000 to $250,000 or more. And that includes full envelope rework, adding insulation on the outside, new cladding systems. We're doing some addressing to various degrees the foundation insulation below ground. One strategy for that, a lot of contractors are hydrovacing around the perimeter, just 6 inches, and then dropping down 4 inches of XPS insulation to get some insulation down there. Others are just going down several inches below grade. It all depends on the homeowner's budget. But we're addressing the exterior insulation like that, topping up the attic insulation, doing specific air sealing approaches, and then also upgrading the mechanical systems, installing an HRV or ERV. We're putting an air source heat pump typically in these things, and then adding solar on top. So all that stuff's included, but that's a massive price tag that's out of reach for so many people. So we have the people that have the equity in their homes, or they have other access to funds to afford that, and different government programs that might come and go to help cover some of the cost or give low interest financing are great. But the question for me and what we've integrated into the course is like, yeah, here's a whole deep energy retrofit, but also what are the key considerations when you can only do part of it?
Where do you hit? What's your low-hanging fruit, so to speak, at that point? Or what steps do you have to get to maybe 80% of a zero energy house?
Or I think the key thing to make it the most value for a homeowner is, what are the systems in your home that are aging out? Do you need new windows? But your cladding's in better shape and you really can't afford to do that whole thing. So let's do the windows now and let's plan for the cladding in another 5 or 10 years. But how do you plan for that interface between the windows and the cladding to minimize rework? And it's like, yeah, you can put some battens around the windows or some boards around the windows that you can just pop them off and do the tie-in easily. But also, how does that window detail behind that with membranes and such? And on the mechanical system, and this is a really big one, it's like, okay, ideally in the retrofit process, if you're doing it at multiple stages, the mechanical system comes last. But what do you do? And this happens every winter across Canada. It's minus 20 outside, 0 Fahrenheit, and my furnace dies. And I haven't had a chance to improve my envelope yet. This hasn't happened to me. I've got enough warm bodies in my house. It's not as impactful right away. But if your furnace dies, you need that emergency replacement. What do you do? And that's part of having a plan and having some contingencies in there. It's like, okay, with a heat pump, great. Let's get a cold climate air source heat pump installed. I know it's going to provide great heating down to about the 0 or plus 5 Fahrenheit or minus 15, minus 20 Celsius. Those are not direct translations. Those are just ballpark areas. But it's going to serve me well down there. And I know a couple weeks out of the year, I'm going to need a bit of supplemental heating to hit that. So let's install a bit of electric resistance heat to provide that. And also, when you haven't improved the envelope yet, you can size your heat pump to be what they need. And you're just going to rely a little bit more on that supplemental heating up front is one strategy that's been discussed. Or do you look at a hybrid system? The other consideration too is standard life of a furnace. You're looking at 15 to 20 years. So do you get a new natural gas furnace, which is prevalent across Canada, and then tie in a heat pump to that as well at the same time? But the other consideration too, the vast majority of homeowners, when you have a furnace fail, you don't have the money to replace the furnace in the first place, let alone pay extra for a heat pump system. So those are all the considerations. And sadly, there's no easy answer for all of this. And you tack on top of all of the considerations you need for a deep energy retrofit or to build new homes better in the first place. Tack on top of that the labor shortage, which in some areas of Canada has been doubling the build time of a home just because the labor is not there to complete it, let alone staffing up a whole new industry for retrofits.
Yeah, that seems to be a problem in many, many places, many areas of the world. Realistically, we're looking at a lack of skill and a lack of people with those skills to be able to do all this work that we want to do.
Yeah. And one thing I think is great that you've interviewed some great people on the podcast over the years that I see happening across the States, and I haven't really seen it happening in Canada. Someone can connect with me on LinkedIn and tell me if it is somewhere. It'd be great. But the amount of trades integration into high schools in the United States is far beyond what I've seen in Canada. Many areas, like locally in Calgary, the high school I went to, we had construction and we had automotive mechanics. And that was the trades. And there are high schools, there are a few more programs now, but I've seen coming out of the States, there's like full, like a little HVAC course as part of high school, or getting into some kids in high school, not just doing some little, let's build whatever thing you want out of wood using the tools we have in the shop. But in the States, what's his name? He's in Illinois, where he's running a high school class and they're building homes every year.
Blomquist?
Yeah, Matt Blomquist.
Matt Blomquist, yeah. That's great work. Like, how can we have that happening in more places, not only in the States, but up in Canada too?
Yeah, Matt does a great job with his program over there in Taylorville. And that happens in a few high schools. I won't say all of them, but it was very big. And we've actually gotten away from it for a while. And now it's starting to swing back again with the resurgence of the trades. It's starting to show up more in high schools.
Yeah. And I think with the trades and technical careers, whether or not you're building homes or doing HVAC labs in high school, it's how do we do more outreach to present trades as a more viable career? It's not like it's been pushed for decades. I remember it was pushed for me in high school. You got to go get a university degree. Get a university degree. I don't like the thought of university. I'll go to technical school.
I don't know. I see it happening organically in the world today, where people are realizing that there's good paying jobs in the trade. So I think it's swinging naturally that direction in a lot of regards. I see a lot of people in social media, parents saying, hey, I'm recommending my kids go to the trades. I've got a degree. I'm still paying it off. And no, they don't want to do that. Go to the trades, kid. And I think that's encouraging.
And my thoughts and how my journey led, like up until the time I was an aircraft maintenance engineer in Canada, I did that for about 4 years. Every skill I had through the various jobs I had was all labor. And my biggest concern was what happens if I get injured and I can't perform a labor job anymore. Like, not I'm going to be laid up in bed the rest of my life, but I just can't do the same level of labor work. And if I don't have enough experience to get into a management position, what do I do? So moving into architecture, it's more of a desk job. I spend a lot of time on site inspections and stuff. But in my opinion, I think the ideal, and I've told my kids this a bit, they're now making decisions as to what they want to do after high school. My oldest one's graduating. I may have already said that, I think. But in my world, my view, the ideal is get a trade and then get some training for something that could be more of a desk job if you're not able to do the labor. And then you can be well-rounded. Maybe it's a business degree or diploma or something like that, which can be applied to your trade if you run a business.
Or even if you just work in a business or help manage a business, you don't have to even own it to be able to apply that stuff. Just working in the business, but understanding how it flows and how the world functions is very, very helpful.
Yeah.
And provides the opportunity to respect another segment of the workforce.
Mm-hmm.
100%. We talk about that sometimes where we talk about cross-training and getting people in different departments, even within TruTech, to see what's going on in different departments and how another department does its job and what they have to do on a daily basis to make that flow.
Yeah. I like the cross-train thing. That's something that needs to happen even within industries as well. Like, there's one lab we were planning. One day, let's have some architects and engineers get their hands dirty. It hasn't come to fruition yet, but the idea was, it's like, okay, let's take some commercial wall assemblies and let's focus on airtightness. Let's bring a bunch of architects and engineers into our lab and have them, okay, you're doing this assembly, you're doing this assembly, build this little box of this assembly, and then let's test it and let's see how airtight you made it. Because that was when I was doing building science. I spent half my weeks on site, the other half my weeks at my desk writing reports for my site reviews and planning the next projects. And for me, when I was drafting and creating the details, it was nice working for such a small firm where I did every step of the process, from initial investigation to preparing the drawings and specifications package to managing the repairs. It was great, but it was getting on site when the repairs were completed and seeing, okay, here's the detail I drafted. Here's how the contractors are approaching it on site, and here's the struggles they're having. I'm able to apply that to the next detail I do. Whereas someone sits behind a desk drafting or planning something's, the BIM's great to be able to do some great 3D models and check for interference and positive energy or energy vanguard, creating some nice 3D drawings for your mechanical system where all the ducts are going to go and everything. That's great. We didn't have that technology a couple decades ago, but still there's even just that little bit more of an advantage. I would say more so on the building envelope side, to get on site and see how these things are actually done. And it's great to see all the content creators out there in the high performance building sphere. I'm glad to see it all in the States. I wish there's more happening up in Canada of showing here's projects that are going and getting some good video, how things are going together and what the considerations are.
Yeah, because that's one of the hardest things for a worker in the field to do, is to take what's on a drawing and translate that into what's in front of them when they pick up a board, when they pick up an air sealing, or they pick up a membrane, and they have to apply that. There's not a translation made for them. They've got to figure out how to do that out in the field. And I'm really excited to hear about some of the training you have, because that's a big piece. They've got to know how to put all that together. We'll say there's no Lego instructions that are just step by step, put this brick here, put this brick here, that comes with a building.
Yeah. And there's a learning curve. And I had two thoughts as you're saying that come to my mind. It's like, one of the things is when an envelope engineer goes out to do a site inspection, and I see some guys out there that's like, hey, this isn't how I drew these windows to be detailed. And a lot of the perception on sites that I saw is, oh, here's the envelope engineer, the envelope consultant coming through to tell me how I'm doing my job wrong and how I need to correct it. You guys got to rip it off. That's not as per drawings, redo it. But I always took the approach of saying, hey, here's what you did. Here's what we drew. This was the plan. Here's why it's wrong. And here's what, try and explain the theory behind it rather than just saying you did it wrong. Like, it doesn't help any area of life. It doesn't really help much if someone just tells you you're doing it wrong. We need that critique to show how can it be done right?
Yeah, and why you should do it right, because it may help with that life of the building 10, 20, 30, 50 years down the road, or it may make such a big difference in the occupant's comfort or whatever.
Yeah, it makes a difference down the road. And that's my biggest concern in the retrofit industry right now. And why we need training is because you're taking an existing building, you're modifying that envelope of it. And if you don't thoroughly understand the building science of that, you can create some significant issues. My biggest concerns are that something's going to get most likely unintentionally messed up. And there's going to be some very costly failure. And sadly, I know from my experience from just reviewing new builds, this is going to happen. It's tragic, but it's going to happen. But how do we minimize that? And hopefully minimize some big public black eye on the news to the retrofit industry, which is going to cause a lot of people to pause in considering, should I get a deep energy retrofit done or should I just keep my house as is? We see stuff like that happening in the UK right now and how spray foam was applied and different strategies that were used. We have insurers refusing to insure homes where they spray foam the roof assemblies. We can't have that happen over here.
So as we wrap up here, what's the best way for people to connect with some of this awesome learning? You mentioned the guidebook. Are there other similar assets?
The guidebook's what we're working on right now. If someone's in the Alberta area and looking for some great resources, and I can send you guys links to this after the call here, Alberta Eco Trust has developed an NBIX, the Emissions Neutral Building Information Exchange. And they've got a whole resource library providing a lot of links to, they're knocking down the silos and they're sharing a lot of resources from across Canada. There's the LEAP Wall Assemblies Guide that Natural Resources Canada came out with last year, which show here's some high performance assemblies and breaks into the categories of how you can do a higher performance wall assembly and has a lot of great technical information and details in there. The other thing too, I could share you with our link just to our research group's website as well, to SAIT, our Applied Research and Innovation Services group. We've just talked about the green buildings area, but we have another research group that is focused on advanced materials and manufacturing, and we're collaborating with them on how that integrates into construction space as well. We have another group that focuses on manned systems like drones. I did not know, and you probably didn't know, there's a company out of Switzerland. There's a couple companies out. They make these like mini helicopters. It's like a 6-foot or 8-foot long helicopter with a little turbine engine, and it's a drone. So it gives you much longer range. So we have a research group that's focusing on how we can utilize drones in various industries, from mapping, flying by with ground penetrating radar and things like that. We have another group focusing on energy systems on the industrial side as well, and providing services for the oil and energy industries as well. Like there's a whole lot of different amazing research happening across our applied research department beyond just the green building space.
Very good. We covered a lot of ground, Ben. I really appreciate you coming on the podcast, and thank you for being such a loyal listener and a first-time caller. We'll collect some of these links up and put them in the show notes for people to pursue a lot of these concepts that you mentioned today.
All right. Sounds good.
Thank you.
Thanks.
Thanks.
Thanks for listening to this episode of the Building HVAC Science Podcast. If you're in the market for tools or test instruments mentioned in our podcast or just in general, take a look at what our company, TruTech Tools, TruTech Tools.com offers. You can use the offer code HVACBS for a nice discount. The Building HVAC Science Podcast is a production of TruTech Tools Limited. In full disclosure, I'm the owner of TruTech. And the opinions expressed are those of my guests, my co-host, or myself, depending on who is speaking, of course. And we got some great quotes we extracted from this episode. You can't have a green building if you ignore building science. It's the foundation for comfort, health, and durability. The real challenge isn't technology, it's training enough people to use it right. And we don't need more silos in the industry, we need bridges. Thanks again for listening to Building HVAC Science. If you want to reach out and get in touch with us, contact us at marketing@TruTechTools.com, TruTechTools.com. Again, thanks for listening, and we hope you're enjoying the Building HVAC Science Podcast. Until next time, take care.